This is an image of a transverse wave. Equilibrium is the center point or 0 point of a wave.
The highest point with the greatest displacement from the equilibrium point is known as the crest. A wavelength is one complete cycle of a wave and can be found from crest to consecutive crest or trough to consecutive trough. The lowest point where the displacement is the greatest is known as the trough. The amplitude of a wave is simply the distance from equilibrium to a point of greatest displacement, which is the crest or the trough. The period of a wave is the time measurement of the particle in the medium to take one complete vibrational cycle. Inversely, the frequency of a wave is the number of periods occurring in a designated time. You can distinguish these terms by understanding that periods are the number of seconds per cycle, while frequency is the number of cycles per second. Waves travel through mediums, which are materials or substances in which carry the wave. Some examples of mediums include air, water, solids, and any matter. Both longitudinal and transverse waves move in forward or backward direction, yet the direction of the particle motion varies. A transverse wave is a wave in which particles of the medium, the substance which the wave travels through, move in a perpendicular direction to the direction of the wave. Propagation is another term for the way waves travel. An example of a transverse wave includes a ripple in a pond. Seen in this diagram of a transverse wave, the particle movement is vertical, while the direction of energy transport is perpendicular to that. An example of a transverse waves include light waves and electromagnetic radiation. This is proven in the fact that light displays the Doppler effect and can reflect, diffract, and refract, which are wave qualities. The Doppler effect is the change in frequency of a wave for an observer moving relative to its source. An example of the Doppler effect is when you move closer to an ambulance with a siren, and sound or frequency of the siren increases while the wavelength decreases. The qualities of reflection, diffraction, and refraction are used when a wave reaches the end of a medium, causing the wave to bend, spread, or reflect. Another example of transverse waves is S-seismic waves. S-seismic waves are the type of waves you feel during an earthquake. Longitudinal waves is a wave where particles of the medium move in a parallel direction to that of the wave movement. Instead of the crests and troughs of transverse waves, longitudinal waves have compressions or refractions. Compressions are regions where the particles of the medium are closer together, and a refraction is where the particles are further apart. Wavelengths can be found from compression to compression or refraction to refraction. As seen in this example, the particle vibration and direction of the energy is parallel. Some examples of longitudinal waves include sound waves and seismic P waves. P waves travel the most rapidly out of seismic waves and therefore reach seismograph stations first. Seismographs are instruments that measure and record details of earthquakes. P waves can be used to determine the distance of an event by computing the unique time and location on the planet for the event, such as an earthquake. This is used to calculate the hypocenter, the point where an earthquake rupture begins.